Very good afternoon. Today we are going to do an important problem under bilinear transformation. The problem is to find the bilinear transformation which maps the points z equal to minus 2i comma I comma infinity onto w equal to 0 comma minus 3 comma 1 by 3 respectively. Now we also want to find the image of modulus of z. Okay, modulus of z, and that modulus of z is less than 1. Okay, so now solution the points are given for z and w. The z points are given by z1 equal to minus 2i comma z2 equal to I comma z3 equal to infinity, and w1 equal to 0, w2 equal to minus 3, w3 equal to 1 by 3. We know that the formula for bilinear transformation is w minus w1 into w2 minus w3 divided by w minus w3 into w2 minus w1 equal to z minus z1 into z2 minus z3 divided by z minus z3 into z2 minus z1. Okay, here the only point having infinity is z3, so we can do the following step: w minus w1. I am not going to substitute any values here, I am just rearranging the things. W minus w1 into w2 minus w3 divided by w minus w3 into w2 minus w1 equal to z minus z1, taking z3 outside, and we will have z2 by z3 minus 1 divided by z minus z3 of z by z3 minus 1, z by z3 minus 1 into z2 minus z1. Z2 minus Z1. So we get Z3 and Z3 cancelled, and these two terms will become 0, because anything divided by infinity will become 0. So we get the values other than these terms, Z2 by Z3 and Z by Z3. Okay, now we can start substituting the values. So W minus W1 is 0 into W2 is minus 3 minus 1 by 3 divided by W minus 1 by 3 into W2 minus W1, that is minus 3 minus 0, that is equal to Z minus Z1, that is Z plus 2y into 0 minus 1 is minus 1 divided by, I should put 0 also, 0 minus 1. Here we will have 0 minus 1 into Z2 minus Z1, that is I plus 2I. So we get, so this is minus 9 minus 1 is minus 10. So minus 10 W divided by 3, okay, whole divided by minus 3W plus 1, that is equal to minus of Z plus 2I divided by 3I, minus of 3I. Now we can take minus in the denominator of 3 minus 3W plus 1. So we get minus of 10W by 3 divided by minus of 3W minus 1 equal to minus of Z plus 2I divided by minus of 3I. All these minus will get cancelled. Okay, all these minus will get cancelled. Now we have to find the value of W. The value of W. For that we are writing 10W by 3 into 3I equal to 3W minus 1 into Z plus 2I, so that we get so that we get 10IW 10IW equal to 3WZ minus Z, then plus 6I so it is 6IW. See here, it is 6IW. Okay, 3WZ minus Z plus 6iw minus 2y. So now we can bring everything on one side, all the w's on one side, which will make our process very simplified one. So we get 10iw minus 6iw minus 3wz. Okay, now these are the only terms which involve w along with z or not, but these are only terms involves w. So we shall take the terms free from w on other hand side. So we get minus of z plus 2i. Okay, so this implies 10iw minus 6iw is 4iw, then minus 3wz equal to minus of z plus 2i. It implies we shall take w outside, so we get 4i minus 3z of w. 4i minus 3z of w equal to minus of z plus 2y, which implies w equal to minus of z plus 2i divided by, so taking minus outside we get minus of 3z minus 4i. So these two minus will get cancelled. Finally we get w equal to z plus 2i divided by 3z minus 4i. So this is one result. Okay, this is the Bilinear transformation of this is required transformation. Okay, w equal to az plus b divided by cz plus d. So we can write it as w equal to 1 z az plus b, so 2i divided by cz, that is 3 z, then divided by plus minus 4i az plus b divided by cz plus d, which is in the form of az plus b, which is in the form of w equal to az plus b divided by cz plus d, az plus b divided by cz plus d, comma ad minus bc is not equal to 0. Okay, now we can box it. It is in the form of, okay, it is not necessary to write all this. You can stop here and you can simply mention ad minus bc is not equal to 0 here. So what is a, that everyone knows, 1, this is d, this is b, and this is c, so that is not equal to 0. Okay, you can verify also if necessary. 1 into minus 4i is minus 4i minus BC is 2i into 3 is 6i, that is 6i. Okay, A into D is minus 4i, B into C is 6i, that is equal to minus 10i, which is not equal to 0 is also verified, but it is not necessary to show all these things. Okay, you simply stop here and you can write AD minus BC is not equal to 0 in this transformation. Okay, now we want to find the image of modulus of z less than 1. Now we have to find the image of modulus of z less than 1. So to find the image of modulus of z less than 1, we have to find what is z first. We have to find what is z first. Okay, so we have to find that to find z. So how to find z? So to find z, we are considering the equation w equal to z plus 2i divided by 3z minus 4i. Okay, so we shall cross multiply this 3. Now we have to get z on the left hand side and all the terms on the right hand side. Okay, so 3z w minus 4iw, then minus z minus 2i equal to 0, which implies 3w minus 1. Okay, 3w minus 1 of z, 3w minus 1 of z minus, okay, 3w minus 1. Okay, this is first term, 3w minus 1 of z equal to minus 4iw, then minus 2i equal to 0. Okay, now it implies that z equal to, all these terms will become positive, z equal to 2i of 2w plus 1 divided by 3w minus 1, 2i of 2w plus 1 divided by 3w minus 1. Okay, so this is the value of z. This is the value of z. Now we have to write what is modulus of z, image of modulus of z less than 1. That is, to find modulus of z less than 1, we are considering modulus of z. To find modulus of z less than 1, what we are going to find? To find image of modulus of z less than 1, consider the above equation z equal to, okay, consider this, z equal to, consider z equal to 2i of 2w plus 1 divided by 3w minus 1. Okay, what is w? W is u plus iv. So z equal to 2i of 2 into u plus iv, okay, plus 1, okay, plus 1. divided by 3 times of u plus iv minus 1. Okay, now z equal to 2 times of, so we have to do the calculations very carefully. Okay, so if we get any confusion means we shall do step by step. First we shall write 2i outside and we shall multiply 2u plus I into 2v plus 1. Okay, plus 1 divided by now multiply, we shall multiply it afterwards, u plus iv minus 1. This is equal, now multiply by 2i inside, so we get 2 into 2i is 4i u, then I square is minus 1, so minus 2 2s are 4v, then plus 2i plus 2i divided by 3u plus I into 3v minus 1. Okay, now we can split real and imaginary parts as well. The real part is minus 4v, the imaginary part is plus I of 4u minus 2 divided by okay, we have to check this, minus 4 we have to check, so it is plus 2, 4u, if I take common also 4u, it is plus 2. Okay, 4u plus 2 divided by it is 3u minus 1 into, sorry, plus I into 3v. Okay, 3u minus 1 plus I into 3v plus I into 3v, so we get plus I into 3v. This is our z, so we shall write z separately here. We get z equal to minus 4v plus I into 4u plus 2 divided by 3u minus 1 plus I into 3v. Okay, this is the z value equivalent to the above z value. Okay, so we shall box it also. Now we shall find the modulus of z. So now it will be very easy. Okay, to find modulus of z, so taking modulus on both sides, we get modulus of z equal to modulus of minus, see, when modulus of z equal to u plus iv means what we can do, smallest of x plus iy is square root of x square plus y square. Modulus of z equal to square root of x square plus y square. So we can write the square root directly, or we can take modulus and then we can write. So modulus of z equal to minus 4v plus I into 4u plus 2 modulus divided by you will get actually the whole modulus. You will get first you will get the whole modulus 3u minus 1 plus I into 3v, which implies modulus of z equal to modulus of minus 4v plus I into 4u plus 2 divided by modulus of 3u minus 1 then plus I into 3v. So what will we get? We get modulus of z equal to square root of real term real part square plus imaginary part square. So we get minus of 4v the whole square, okay, 4v the whole square, then plus 4u plus 2 the whole square divided by 3u minus 1 the whole square plus 3v the whole square. Okay, so this is the value for modulus of z, but they have given a condition. The condition is given that modulus of z less than 1, so it implies square root of minus 4v the whole square plus 4u plus 2 the whole square divided by square root of 3u minus 1 the whole square plus 3v the whole square is less than 1. So now we can take a denominator to the other side of the inequality, that is less than. So we get square root of minus 4v the whole square plus 4u plus 2 the whole square is less than square root of 3u minus 1 the whole square plus 3v the whole square. Okay, now squaring on both sides. Squaring on both sides we get now squaring on both sides, we get minus of 4v the whole square plus 4u plus 2 the whole square less than 3u minus 1 the whole square plus 3v the whole square. Okay, now we shall expand this. It is 16v square plus 16u square, then 2 4s are 8, 8 2s are 16, so we get 16u plus 4 less than 9u square, then minus 2 3s are 6, 6 1s are 6, so minus 6u plus 1, then plus 9v square. Okay, now bring everything to the left hand side. We get 16 minus 9 is 7u square. Okay, 7u square plus 7v square. Okay, plus 10, sorry, plus 22u. Okay, 22u plus 3 is less than 0. Now divide. See, this is not the equation of circle. Okay, but if we make a little change to this, we will get the equation of circle. Okay, so that is so the change we are going to make here is dividing by 7. Dividing by 7 implies u square plus v square plus 22 by 7 u plus 3 by 7 less than 0 by 7 you will get, that is also 0. So now we can box it. Now we can box it. Now we can box it. So what is this? What is this? This is nothing but equation of circle. This is nothing but the equation of circle. So when modulus of z is less than 1, that is in the z plane. If it is less than 1 means in the w plane it is less than 0. That is the equation of circle is less than 0. That is interior of the circle we are having. So we can write a conclusion. The image of modulus of z less than 1 is the interior of the circle, interior of the circle u square plus v square plus 22 by 7 u plus 3 by 7 less than 0, or it can be written as equal to 0, because we have mentioned here it is interior of the circle. Interior of the circle, this equal 0, so equals something is equation. Okay, it is inequality whereas it is equation. So this less than is mentioned here as interior of the circular equation. So interior of the circle, that is equal to 0 in the which plane? Since u and v are appearing here, in the w plane. In the w plane. Okay, so this is our conclusion. Okay, now I would like to share another important thing, how and why we are calling this equation, okay, this equation as the equation of circle. Why? It is very new to some of you. Now we are going to see the reason for calling this equation as in the form of equation of circle. Okay, so carefully listen to it. Carefully listen to it. So now we shall start with the basic equation of circle. So we know that the equation of circle, the basic equation of circle is given by x square plus y square equal to r square. So this is what everyone knows. Okay, this is what everyone knows. That is, for this you will have a circle. Okay, you will have a circle of radius r, center at 0, 0. So center 0, 0 in the xy plane. Okay, in the xy plane you will have it. Okay, so this is the equation, basic equation that we know. But you know one thing, if the center is set, if the center, this is for center at 0, 0 and radius r. Radius r units, radius is r here. The equation of circle is this. The equation of circle is this. Now if suppose center at h, k and radius at r means, and radius is r means, radius is r, then we get the following equation, that is x minus h the whole square plus y minus k the whole square equal to r square. So for this I am draw a circle. Okay, if this point denotes h and this point denotes k respectively in x, y coordinates, then center will be here. The center is h, k. With r radius we will have a circle. Okay, we will have a circle. So this is a second equation. Now we are going to the very important part of the session. Okay, now simply expand this. Simply expand this equation will give you x square minus 2hx plus h square, then plus y square minus 2ky plus k square, okay, equal to r square. This is the expansion. Okay, this is the expansion. So I can rearrange these terms as x square plus y square minus 2hx then minus 2ky then h plus h square plus k square minus r square equal to 0. So this is also equation of circle. If this is equation of circle, then expansion of this is also equation of circle, then this is also equation of circle, but I am going to simplify it further by giving this term as C. Okay, now by giving the name this term as C. Okay, so right, now I'm going to have, and see, consider following points. Now I am taking minus h equal to g and minus k equal to f. Okay, minus h equal to g and minus k equal to f, and h square plus k square minus r square equal to c. If I consider these three values, these three replacements, this equation star, this equation will become the following equation: x square plus y square then plus 2gx plus 2fy plus c, okay, plus plus c equal to 0. So this is also the equation of circle, and this equation is called the general equation of circle. This equation is called the general equation of circle. General equation of a circle, of a circle. Okay, here the center is, okay, here the center is, see, we have taken minus h as g and minus k as f. So the center will be center equal to minus g comma minus f, and radius is square root of r square. So radius is how we can get radius: h square plus k square minus c. So here instead of h we are having g and f. Minus h, for minus h we are having g, and for minus k we are having f. So the radius will be given by square root of g square plus f square minus c. So this is the radius. So this equation is called general equation of circle. Okay, so now we have seen the different equations of circle, from basic equation to general equation we have seen. So kindly go through it. So and now you know that, and now you can understand why we call this equation, or this equation to be the equation of circle. See, x square plus y square plus 2gx plus 2fy plus c equal to 0. See, under the points g comma f, if any of the points becomes 0, means you will not get that point, no. So you get this equation, u square plus v square plus 22 by 7u plus 3 by 7, 22 by 7u plus 3 by 7 less than 0, that is interior of circle equal to 0. Okay, I hope you all enjoyed the problem. Okay, so on the next session we shall meet with different problem. Okay, so kindly go through this problem. The problem is very, very important under the topic bilinear transformation. Thank you all for watching this video. Thank you all once again.